Hey vloggers, Ms. Castro here. Hope you had fun at the rally. Here's a shout out to everybody who performed. Great job. Okay, so what we're looking at today is how to use your graphing calculator to construct a scatter plot and then how to analyze the information. So both how to get a line of best fit and also how to find the correlation coefficient, which tells us how strong is the correlation between the two sets of data. So what we're going to do is we're going to actually use this data right here. So I gave you this worksheet, and we're going to use this data. I have entered in just the first A through N because I don't want you just copying my answers off of what I do and just writing them down. I want you to actually do the whole thing. So you are going to put in all 21 team members. I only did 14 of them, okay, but you're going to do all 21. So you're going to have different answers than what you see me getting. So what we're going to do is we are going to make a scatter plot. You're going to sketch it down here, and I'm going to run through how to do that using the notes that I gave you. So here's the notes for making a scatter diagram. We're also going to find the line of best fit. That's called the least squares regression line. And if you want to know exactly how is this calculated by hand, I'm going to let you research that yourself. Go to Google. Google it, least squares regression line. How is it calculated by hand? Okay, so if you're curious about that, go ahead and do that. But basically, it's a way of finding a line that best represents the data, if it's a linear relationship. And then we're going to do something called calculating R, which is the correlation coefficient. And that tells us how well does that line of best fit represent the data. Does it represent it really well, or is it kind of a weak relationship between the two sets of data? Okay, so we'll talk about that in a minute. So first of all, let's go ahead. You're going to put in the data into L1 and L2 to save time. I already did that. Where is it? I already put in my data into L1 and L2, but remember when I'm running through this, I did not put in all the data on mine, but you need to put in all the data on yours. That way you can't just copy my answers. You have to actually do it. All right, so this was at stat, edit, enter, and enter in your data into L1 and L2. Remember, if you have data in there already, to erase it, you hit the up arrow. So you select the column heading, and I'm not going to erase my data because then I'd have to type it again, but I'm just showing you over here. Hit the up arrow, and then hit clear, and then enter. And then that'll clear the entire column. Okay, so I have my data already put in into L1 and L2. So now we're going to make the scatter plot. So we entered in our data into list 1 and list 2. Now we're going to do second, y equals. That gets a step plot. And we're going to set up plot 1. We're going to turn it on. I already have mine turned on. Okay, but if yours was in the off position, go ahead and turn it to on by using the arrows to select on. And then we're going to say what type of representation do we want. So far we've done histograms and we've done box plots, and this is a box plot with calculating outliers. So if you want the calculator to calculate outliers for you, it does it automatically right there. Okay, but we want for this, we're going to do scatter plot, and we're using list 1 and list 2 for our x and y variables. Pick whatever mark you want. Mine, I'm actually allowed to have colors, so I can choose whatever color I want. What do I have in here? I want red. Okay, and then I'm going to hit enter. Actually, I don't need to press enter. I'm going to do zoom stat plot, which is option 9. So I'm going to choose option 9. So I can scroll down to that, or I could have just typed 9 on my keypad, and then it sticks it in. Oops. Sorry, you weren't supposed to see that line yet. Okay, here, I'm going to hide that. Take out the line. We don't have the line yet. Let's do that again. Sorry. Okay, so we hit zoom, option 9, and there's my scatter plot. So that's what I want to see on the paper right here, except that yours will have a lot more dots than that. But you're just doing just a general sketch. Doesn't have to be perfect by any means, but I want you to be putting in all these numbers, and you'll get a scatter plot that looks something like mine. Okay, so then the next thing I want to do is I actually want you to find the line of best fit. So it doesn't actually say that on here, but we're going to add it in. Okay, so after you plot it on here, I want you to find the line of best fit. That's called the least squares regression line. Okay, so that's also called a line of best fit. Okay, I want you to have this on this paper as well. So I'm going to do mine. Yours, of course, is going to be different than mine. Okay, so to get the line of best fit, we're going to go follow these directions. We already have our data in list 1 and list 2. So now we're going to go stat calculate. So it doesn't say that here, it just says stat arrow over. So that's to calculate. Stat, we're going over to calculate. Okay, so let's add that to the notes because our notes are not very complete. Calculate. Option 4, I think when we did this in class before, I chose option 8. It doesn't matter. They're both the same thing. They just give you it in a different order. So if we do option 4, A is going to be the slope and B is going to be the y-intercept. Or also saying A is the gradient or slope, B is the y-intercept. Whereas if you choose option 8, A is the y-intercept and B is the slope. Okay, so it doesn't actually matter which one you use. But we'll go ahead and do the one that's on here, which is option 4. So I'm going to choose option 4. It asks me what do I want to use. We want to use list 1 and list 2. So we just keep hitting enter. Frequency should be blank. The store, I should look this up because I have a feeling we can probably have it store the equation for us, but I don't know how to do that. So that would be something, if somebody wants to look that up and then show it to the class, that would be awesome. What does this function do? Figure it out. Help me with that. Okay, and then I tell it to calculate by hitting enter again. And notice it gives me A, that's my slope, and it gives me B, that's my y-intercept. Okay, so for mine, not yours, my line of best fit would be y equals 0.849, because I'm using 3 significant figures, x minus 72.3. I'm using 3 significant figures. Now I'm going to actually see if that really does match my data. So now I'm going to hit y equals, and I'm going to type in this equation, and then I'm going to have a look at it and see if it actually does line up well with my scatter plot. So I'm going to have 0.849x minus 72.3, and I'm going to go ahead and do zoom 9 again, and let's see if that line looks good. And it sure does. That looks like a very nice line of best fit. Okay, now how good of a fit is it? That's what we call the correlation. Okay, how good of a fit is this? So that's what is calculating R is about. That's called the correlation coefficient. So the correlation coefficient tells us how good is that line matching the data. So notice, if you notice back over here, sorry, let me go back over here. Notice over here when it was saying to find the line of best fit, the least squares regression line, it said that the window should look like this, but when we actually looked at our window, if I bring that window back up again, notice mine has the y equals ax plus b, and I have the a and I have the b, but I'm missing this r squared and this r. So R is what is called the correlation coefficient. It tells us how well is our line matching the data. How strong is the correlation between the two pieces of data. And we're going to talk about correlation much more in class next week, but we just want to know how strong, in other words, how close to the line are all those data. Are they really far away from the line, or are they really tight to the line? So I want to get these on my screen. Why aren't they showing up? So the reason why they're not showing up is because we have to turn diagnostic on. So if those numbers are showing up for you, awesome. If they're not, then you're going to have to follow these directions right here. So mine are not showing up, so I need to do this. I'm going to hit second, 0. Where's my 0? There it is. Second, 0. And that brings up the catalog. In the catalog, I'm going to select diagnostic on. So I'm going to have to scroll down a long ways because it's in alphabetical order. I don't know a fast way to get there. So I'm just scrolling. When I see diagnostic on, there it is. I'm going to select diagnostic on by hitting enter, and then enter again, and it tells me it's done. Sorry, there it is, diagnostic on, enter, enter. And now I'm going to do this again. Stat, calculate, that little arrow means move to the right and select calculate. Number 4, enter, 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 enter. And now look how I get extra information. Now I have r squared and r. The one we're interested in is just the r. So r, our correlation coefficient, is 0.922 if I do 3 significant figures. Now remember, that's for my data. I only put in 14 of the data points, so you're going to have a different answer. So I'm going to say my r is equal to 0.922. Okay, so what does that mean? What does that mean if I have a correlation coefficient of 0.922? All right, so that comes to the rest of the notes that I gave you. So if we turn over to here, correlation means how strong is the relationship between our sets of data. Okay, so we're going to go ahead and look at this. We want to be able to calculate just how strong the correlation between two variables is. In other words, how close, if I go back to my Zoom 9, how close really are all my dots to that line? So looking at this, they look like they're pretty close. I mean, they're pretty much following that line, but they're not completely on it. So the R gives us an idea of how tightly they are to that line, or if they're like really far away from it. So we want to be able to calculate just how strong that correlation is. How close are the points to that line of best fit, or the correlation between the two variables. This is called the Pearson's correlation coefficient, or R value. The formula is complicated, and so we're not going to learn it. We're just going to use a computer or a calculator to determine it. For the IB test, you're not required to know the formula. I don't even know what the formula is. I'd have to look it up. Only how to calculate it. It has to do with like making a square and have the square touch the line of best fit, and you find the area of the square, and then you find the average size of the area of the squares, or something like that. I can't remember. All right, so for positive linear relationships, okay, that means the slope is positive. The value range for R is between 0 and 1. So the highest R you could ever get is a 1. You can't get anything bigger than a 1. 1 would be a perfect correlation. So a perfect correlation would be every single one of these points would be exactly on that line of best fit. It would hit every single data point. They would line up in a nice straight line. Okay, and 0 is no correlation. In other words, the dots would be like scattered all over the place, and it wouldn't even be possible to draw a line of best fit through them. So ours obviously has a pretty good correlation. These dots are all pretty much lining up with that line. Okay, for a negative linear relationship, that means a negative slope, the values can range from -1 to 0, where -1 is a perfect correlation. So in other words, you would have a slope that's going down, but all the dots would be lined up exactly on the line of best fit, but it would just have a negative slope. Okay, so that's a perfect correlation that's negative. And of course, if they're just scattered all over the place and there's no real way of drawing a line of best fit, the correlation would be 0. Okay, independent variable versus dependent variable. We talked about this a little bit in class. Independent variable can be thought of as what you put on the x-axis. It's also like the input. Okay, so this would be your x-axis. You can think of it as the input. In general, if we think that one value affects the other one, that would be our independent variable. And then the dependent can be thought of as that's the y. Actually, why did I write x-axis? X value, x variable. I'll just write x. Okay, so what you put on the x or the input, y, you can think of that as the output. So in other words, if this happens, then it affects this. So an example, amount of fertilizer is going to affect the height of the plant. So x, our independent variable, and y, the height of the plant, is dependent on how much fertilizer we put on. Okay, so that's kind of in general how we think of the x-axis and the y-axis as independent and dependent. And we're going to see in class, though, you got to be careful. Sometimes these two things are not input and output. Sometimes you can get a correlation between two items that have absolutely nothing to do with each other. So you'll see that in class next week. Okay, so input and output, let's see. I think that's all I want to say there. Now, I also gave you a nice little chart to kind of give you an idea about that R value. So if R is equal to 1, see how all those points line up perfectly in one straight line? And then there's different ways of describing the correlation depending on the R value. So let's look at the R value I got. And remember, you're going to get a different R value. I got 0.922. So how would we say that? We would say that would be right here. That's a strong positive correlation. So describe the relationship. I have a strong positive correlation. Strong positive correlation. But you still need to enter in all the data and figure out yours. Okay, so I had a strong positive correlation looking at this chart. And the most important thing to recognize is it positive or negative? So ours was positive. It has a positive slope. And then the more linear it is, the closer it is to 1. So notice this one down here. See how you couldn't even draw a line through that. How can you even say that's a positive correlation? It looks exactly like this one. Okay. How can you say that has a negative correlation? They both look like there's no correlation whatsoever. Okay, so that would give you an R value that's less than 0.1 or greater than negative 0.1. Okay, so again, on here, you need to make your own scatter plot. Make sure you use all the data here. You should get a different line of best fit. It should be different than mine because I did not put in all the data, so make sure you put in all the data. And then given your R value, you might have a different definition here. Oh, and by the way, it is possible to have correlations that are nonlinear, but we are just going to be looking at linear ones. So this is kind of not really an option. We're going to have a linear relationship on what we're looking at here. But it is possible to have relationships that are nonlinear. But ours we're just looking at linear. All right. I think that's it for the notes. And that's pretty much all you got to do on this. Just follow, put the data in, figure out how to get all those values, make a sketch of your scatter plot, and tell me the line of best fit and the R value. Oh, which is the independent variable and which is the dependent variable. I'll let you fill that in based on what I just talked about. Okay. See you next week.